This is BYU Math 112. In this video we will discuss textbook section 3.7 and exercise like number 1. Our problem reads: a particle moves on a vertical line so that its coordinate at time t is y equals t cubed minus 12t plus 3 for t is greater than or equal to 0. Part A, find the velocity and acceleration functions. So for part A, velocity is the derivative of position. So we'll label it v of t. The derivative of t cubed is 3t squared. Minus 12t derivative gives us minus 12. And then the derivative of the constant 3 is just equal to 0. So that's our velocity function. Acceleration is the derivative of the velocity function. So our derivative of 3t squared is 6t. And the derivative of minus 12 is just 0. So there we have part A. Part B, when is the particle moving upward and when is it moving downward? Any question that asks us when a particle is moving in a certain direction, the first thing that we always want to do is figure out when velocity is equal to 0. Because on either side of 0 it's going to be going in a certain direction. It's easy to pick out the time intervals when we know when velocity is 0. So we want to solve 3t squared minus 12 equals 0. First thing we want to do is divide out the 3. So we have 3 times t squared minus 4 equals 0. And then t squared minus 4 is the difference of two squares. So we have t minus 2, t plus 2. Then we use the zero product property, which says if we are multiplying any number of things together and we get 0 as our answer, then at least one of the things that we multiplied had to give us 0. So 3 can't be 0, but t minus 2 can equal 0, and t plus 2 can also equal 0. So if t minus 2 equals 0, then t is equal to 2. If t plus 2 is equal to 0, then t is equal to negative 2. So these are the 2 points at which my velocity is equal to 0. Now this second one is a different case because my function is only defined on t greater than or equal to 0. I toss this one out. And so the only one I'm going to be concerned with is when t is equal to 2. So what we want to look at now is what happens to velocity on the intervals from 0 to 2 and 2 to infinity. Alright, so if I look at velocity, what happens at time t equals 0? Well, then I'm substituting 0 back in. So v of 0 is equal to 3 times 0 squared minus 12. And what sign is that going to give me? It's going to give me a negative sign. So on the other side, at something like v of 3, 3 times 3 squared minus 12, 3 times 3 squared, which is 9, is 27. 27 minus 12 is going to give me a plus. So this tells me it's moving upward here and downward here. And again, upward is the positive velocity direction, downward is the negative velocity direction. So now we move to part C. Find the distance that the particle travels in the time 0 to 3. So we know it's moving down from 0 to 2. So at time equals 0, I'm going to have y is equal to 0 cubed minus 12 times 0 plus 3, which comes out to 3. At time t equals 2, I have y equals 2 cubed minus 12 times 2 plus 3. So 2 cubed is 8. 12 times 2 is 24, plus 3, so 8 minus 24 is negative 16, plus 3 is negative 13. And And then velocity changes direction and it goes back upward. And so we're going to look at where it is on the other end. Y equals 3 cubed minus 12 times 3 plus 3 equals. And so 3 cubed is 27. 12 times 3 is 36. And plus 3. So we have 27 minus 36 is negative 9. Plus 3 is negative 6. Okay, so you might be asking yourself, well, why did they do the 2 in the middle? Because I know that my particle is moving into one direction and then changes one direction, the question asked me to find the distance the particle travels. If I only went from time 0 to time 3, I would look at, it starts at 3 and then it goes to negative 6, so it traveled 9. When in reality, because the velocity changed signs on that interval, it went a different amount. So we started at 3, and we went to negative 13, and then we went to negative 6. So from 3 to negative 13, we traveled 16, and then we went 7 more. So the total distance that I traveled was 23. Which is a lot different from the 9 you would have gotten if you had just gone from 0 to 3. So again, if you're looking at a distance something is traveling, you have to pay attention to when it's changing signs. Because you have to stop. You have to look at the distance you traveled in each sign of velocity, up and down. And for the last one, part E, speeding up occurs when velocity and acceleration have the same sign. Again, speeding up occurs when velocity and acceleration have the same sign. So I can look at my little table I made over here for velocity and say, 0 to 2, 2 to infinity is when I have positive and negative velocity. And I can also add to that, what happens with acceleration? Well, if you remember when we did velocity, the first thing we found was when is v of t equal to 0. So I can go back and do the same thing for acceleration. And we see that acceleration is equal to 0 at t equals 0. So acceleration is only going to have one sign. It's going to be 0 at 0, and then after that, if I pick any positive number and multiply by 6, I know that acceleration is going to be positive everywhere else. So when is it speeding up? Well, when do velocity and acceleration have the same sign? They have the same sign from 2 to infinity. Okay, inherent in this is that they have to have the same sign. So we don't actually count when one of them is equal to 0. And then when is it slowing down? Well, kind of obviously, it's slowing down when they have opposite signs. So we look at the interval from 0 to 2. Now you do notice that I've used a parenthesis here, not a bracket, because acceleration is 0 at time equals 0, and so I'm not going to include that in my interval when it's slowing down. So it's speeding up from 2 to infinity, slowing down from 0 to 2, and that's how we do an exercise like number 1.